So I'm looking at the formula for solving a first order matrix differential equation, right? With complex eigenvalue vector pairs, right? And here, formula, right? But like, where formula, really? So,
Oh.
yeah, war formula. So, the question is, like, can I get this thing? And the answer is yes. So, let's start with what we know. What should the answer be if I have eigenvalues lambda 1 and lambda 2 and eigenvectors x1 and x2? Like if this didn't have this complex nonsense going on, what would you be doing?
Putting it in the...
Yeah, so if there were eigenvalue or eigenpairs, right? Like if we had y prime is a y, and we had it with lambda 1 and lambda 2 associated to x1 and x2.
You would get like c1 and e to the lambda 1.
Yeah.
X1 plus c2 to the lambda 2.
Perfect. Right? We'd have constant e to the eigenvalue times the eigenvector plus constant e to the eigenvalue times the eigenvector. I probably didn't say some t's, but there should be t's in there.
It's implied.
Just put them wherever you
It was a
want,
silent
really,
T.
right?
Yeah,
It's a silent T. Yeah, pretty much. Okay, so let me start here, right? Like, this is the answer I know and love. I understand why this thing works. So let me just assume that that's the same thing, right? You guys actually did some of this the first time I asked you to do these. Right? Usually I just let you stumble into it a little bit. I'm like, yeah, go find some eigenpairs, and you like find some eigenpairs that have i's in them. And then you cram them in here. And you're not actually wrong. Like, it's just hard to see the constants through it. So let's see if we can find that. So I'm going to say we've got y is c1 e to the a plus bi times t. Are you with me?
Yeah.
And then I've got a eigenvector, which is u plus iv. Yep. And then I've got plus a c2, and this is times e to the a minus bi times t times u minus iv. You with me? Okay. So, now, we're going to do a lot of algebra. Going to have to hold on a little bit. So, I've got a C1, and then this thing here is an e to the at times an e to the ibt. Are you with me on that? What's that?
Oh, nothing. I was getting excited and I did a fact. To me, this means factoring. I always like factoring. I get
Okay,
excited.
good.
Sorry.
So then I've got times u, right?
Yeah. Oh.
Plus,
Oh.
plus, yeah, this one, not this one, but that one. Right, so not factor, distribute. So I've got a plus a I, C1, e to the at, e to the ibt, v. You guys with me? That's this shit distributed out. It got longer. Okay. Plus a c2 e to the at times e to the minus ibt. Good, and we're distributing. So we've got times u plus,
No minus.
oops, minus I times c2 e to the AT
A minus. Wait. Sorry.
e to the minus IBT. Are you with me?
Yes.
Okay. So, now, I need to sub these guys out, because I still have i's in e's to the IBT, and here in e to the minus IBTs. So, I'm going to Euler's identity this, right?
Yeah.
So we're going to get, and this is where things get really wild, so I'm going to have an equal sign, and this is going to be a couple of lines, so you'll have to bear with me here. So I've got a C1 e to the AT times u, right?
Yes. Lovely.
Okay, now e to the IBT is what?
Cosine BT plus
Cosine BT
I sine.
plus I sine BT. Guys with me?
Yes.
Okay. So that's this one. Oh god. Plus I C1 e to the AT times the same thing. Oops. Got a B. B times the same thing. So I've got a cosine BT plus I sine BT. With me? Then I've got the others. So that's this one.
Yeah.
And then I need these two. So I've got a plus C2 e to the AT. That one's going to be times u. With me? And then this guy's an e to the minus IBT.
With cosine matter?
So I should have cosine of minus BT, right? Which is cosine of BT. So I use the fact that cosine's even there. And then I have a minus I sine of BT. Are you with me? Right, both of these should be a minus BT and a minus BT. This should be a plus sign to start with. Cosine's even, so the minus sign doesn't matter. Sine's odd, so the minus sign can come out of the argument and be applied to the front. Good? Okay, so that was this term. Okay, now I have a minus I C2. Oh, whoops, you guys let me get away without a vector here. That was a V there. See what I lost?
No, I can't see. I'm kind of standing in the way. Yeah. Oh shit, there should have been a V there.
Yeah, there should have been a V there, but I was standing in front of it. No, you guys.
Come on, Jay.
Okay,
Step up.
so I have this guy, which is minus I C2V, e to the AT. Everything's got an e to the AT in it, right?
Yeah.
It probably would have been smart for me to factor that shit out a long time ago, but I didn't, so now I'm stuck with the damn thing. I've got a V, and then in here I need e to the minus IBT again, right? So same rules apply. I'm just going to copy this thing down so I don't screw it up. I've got a cosine BT minus I sine BT. With me? Okay, so. This is one of those, this is maybe one of the calculations where I'm most happy to have whiteboards that flip over. Because I'm going to need it. I probably need every bit of space I have here and then some. But maybe we'll get this done in the amount of space I have. So, I'm going to distribute these
What?
in.
Are you kidding?
So I had 4 terms, gonna get 8, right? So we have to be careful.
Please factor the
Please, I'm begging you.
Brackets. Bring in the brackets.
Thank you. Thank you.
Yeah.
Thank you.
Oh, parents.
We're rocking.
We're getting serious, guys. The sports.
Okay. So yeah, you guys are doing a great job. So I've got a C1U cosine BT. Goes with me on the first term?
Yeah.
Okay, then I have a, and I'm going to do this. So I'm going to start writing the real ones up here on this line and the complex ones down here. So the next one is a C1U sine BT. C1U sine BT. You with me? So far I've got 2 terms accounted for. I should probably start with something cross off, cross off. Okay. Done, done. Those were this one, this one. Guys with me? Okay, my ending bracket for my A's is going to be over here. Okay, so next term, I have an I in it, right?
Yes.
So when I distribute that, I'll end up with an I cosine BT. You guys see that? So I've got a cosine BT, and then what's the coefficient on it?
C1.
C1 and a V.
Yes.
C1 and a V. You guys with me on that guy? It's okay.
Stress me out, Joe.
Don't worry, we'll get there. We just gotta go slow and mark things off as we do them. So that was that term. Okay, and then the next one's going to get an I squared on it, yeah?
Yes.
So it's going to end up in the real side with a negative sign on it. So I've got a negative, and that's going to be a C1 and a V and a sine. C1, a V, and a sine of BT. Is with me? So that is purple thing, purple thing. Second purple thing done. Okay, so now we're going to aim at these guys. So what's the real part of that first one? Good, I've got a C2, a U, and a cosine BT.
Next one's imaginary.
Okay, so that was this one accounted for. And then the next one's imaginary. And so it's got a minus I C2U. So it's a minus, a C2, a U, and a sine of BT. Is with me? That's this guy. Okay, and back to green. So this guy, that one real or imaginary? That one's imaginary. So that's going to be a minus, and it's in the imaginary column. So it's a minus, and then the coefficients are C2V and a cosine of BT. Is with me on that? Okay. What's the other component?
It's gonna be real possible.
Yeah, so the other component's going to be real, and it's going to have a plus sign on it. You see that? So it's going to have a plus.
Wait,
It'll be negative.
Oh, negative, negative, negative.
Yeah. Wait. But isn't 4 I's? Or wait. So we have negative, negative, but we have 2 I's.
Uh-huh.
Yes, I squared is negative.
Yeah, that's
Okay,
why I said
okay.
negative 3 times.
Wait. Yeah. Yep.
Negative,
No, we're good. We're good.
negative, negative.
We're good.
So I end up with a minus, and I've got a C2 V sine of BT. You guys all with me on this? Okay, so
Get a closing parentheses.
I have a closing.
Yeah.
Oh,
It's all in the same. Thank you.
for the eyepieces. That was good. That makes sense. Okay, you guys with me on this? Okay, so all told, this is still my solution Y, right?
Yeah.
But like,
Hot one.
Cool. I know what that
is
means.
it like? Okay, so what was my goal? What was I trying to do?
You're trying to get back to
Trying
the
to find a
formula,
vector of solutions.
right?
Yeah, I was trying to find a solution that didn't have any friggin' eyes in the damn thing,
Yeah.
right?
Yeah.
You guys see that? Like that's what I was after. I was trying to find a solution without eyes.
You want to look at the spring.
Yeah, I want to see this spring, right? I want to see it in the reality that I'm used to. I want to know what happens in real time, not what happens in in complex time. So, like, okay. So here, where am I setting? Well, this whole bit, right, is like a chunk of a solution. Like that part I feel okay with. This guy feels kind of screwy. You guys see that? So let me spend just 1 second think about the constants that I've got here. Like, looking at constants, you guys see like terms in here anywhere?
Oh.
Like, what do you got? I've got a u and a cosine bt, and then I've got another one over there. You guys see that? So we did this one, right?
Mm-hmm.
Let's do a little bit of this one.
Yeah.
You know, we distributed a bunch.
That's what we're.
Let's see if we can like factor some stuff, right? So I've got an e to the at times this whole silly thing. Yeah.
Yeah.
Okay. So I'm gonna remain having an e to the at times the whole silly thing. So now, looking at my u cosine bt's, I have two of those.
Yes, you do.
There's C1 of them over here and C2 of them over there, so all told I have C1 plus C2 U cosine BTs. You guys see that? And then I've got a minus, and I've got a C1 plus C2 V sine of BT. You guys see that shit?
Can we sit C3?
Still-
C3? Do this again.
So, let me consolidate again, right? So I've got, that's my real part. I've still got plus I, and then here I've got my imaginary part, right? So let me look at my purely imaginary part. I've got a u sine of bt, and I've got a u sine of bt over there as well. You guys see those? So the coefficient C1 minus C2 there, yeah? So I've got C1 minus C2, and that's u sine of bt. Okay, and then I've also got here a C1 minus C2 times a V, yeah, cosine BT. You with me on that? And on both of them, I've got this kind of funky thing where I can factor out.
That's sick.
Oh, and they're constant. Yeah.
Oh, dude.
Where's the other one?
This is the perfect amount of work space for this. It's so cool. So, out of the top,
You're kidding?
out of the first two, right, we're going to factor a C1 plus C2. You guys see that?
Yes.
So I've got an e to the at throughout. So I've got an e to the at And in the top I've got C1 plus C2 times what?
U cosine
Yep, I've got a U cosine BT
minus the sine.
minus a V sine BT.
Plus.
And then I've got my other bit, right? So
Yep.
I've got plus I times C1 minus C2
U
times U
sine B2
sine BT
plus
plus
B.
B cosine BT. Let's see. So that's that paren. Then I need the 1 for multiplying by I, and then I need the bracket for my e to the AT. Bar pointing? What was your question? Really? Like, if you have it, somebody on the recording's going to have it.
It was.
It doesn't matter.
I was just looking at your V. It looked a little bit more U-ish, but then Sage pointed out you didn't have a tail on it.
Yeah, I tail my U's precisely because of that.
Yeah.
Okay, cool.
Sorry.
So, no, you're good. Really, like, I wasn't kidding. If you have that question today, somebody watching this recording later will be like, for clarity, that's a V. Is that what the one?
Yeah.
Okay, R. I'm kidding.
Yeah, R.
Yeah.
Just out of nowhere.
Somewhere in the middle of this problem, an R appears.
That's the final boss.
Okay, so, now, here's the kind of wild thing. These are arbitrary constants, right?
Yes. So a new arbitrary constant.
So I'm going to make new arbitrary
Let's
constants,
go.
right? So I'm going to let my new C1 be C1 plus C2. That one make sense? Okay, then I'm going to do something even weirder. I'm going to let the new C2 be C1 minus C2 divided by I.
Yep. What just happened here? I see the thing he's doing. He's doing
Oh,
clever.
and by that I actually mean let it be I times C1 minus C2.
Okay, yep. He's doing clevers, I think. Yeah.
No, the doctor didn't
No.
He's not a doctor. We all know what he really is.
What the fuck?
What?
Harsh, bro.
Yeah.
I earned that.
Can we cut that out of the video?
No, let's keep
No,
it.
that's
You
fine.
only-
So,
Silly-
look like. So this piece is going to become my C1, and this piece is going to become my C2. You guys all see that? So this whole thing is going to boil down ultimately to the solution y, right, is e to the AT times C1 hat times this quantity, u cosine BT minus v sine BT. Right? Plus e to the AT times C2 hat times, and then this is the one that I screwed up before when I was reading it out of the book, right? So it's u sine plus v cosine, and the reason that they're mismatch, like why did the real parts get mixed with the imaginary parts? You guys see that's what happened there? Because this C2 ate the imaginary part. Right? So really, ultimately, this formula is just the old formula, but rewritten to get rid of the imaginary number by sucking it into a constant. You guys see that? So, if we turn that over, same.
Looks kind of the same to
Yeah,
I love it when a frickin' plan comes together.
that's
You guys recognize this is the exact same thing we did when we were doing springs, right? And we got complex values out of our quadratic.
Yeah.
We were like, well, we guessed e to the RT, so we're just going to keep guessing e to the RT, and then we'll just use Euler's to rewrite it.
Yeah.
And we get some e to the AT and some cosine BTs. Same deal, right? that's all we did. We started here at, I'm going to persist in solving this the way I know how to, and then I'm just going to re-express that in a way that it means something. Right? You guys cool with that? Okay, okay.
So during so when we forget the formula, just
derive it. The exam. Just derive it.
So I made this claim the other day to somebody I was talking to that, like, I actually think a lot of facility with proving things in mathematics is helped by being a bit forgetful. Like, I don't actually remember formulas super duper well. When I got to exams, I just remembered where they came from, and then I'd go get the ones I needed.
Dude,
It's slow as hell. It can be a real problem if you're not really quick with algebra, because you need that time to do algebra and stuff. So if you're not mega quick with algebra, then you have to put the formulas in your memory. If you can't put the formulas in your memory, then you have to be really quick at algebra, because you're going to need to go get the formulas.
Every time I want to use something in trig, I gotta prove the unit circle to myself again.
Yeah.
I have a method of proving it to myself. I don't remember any of the values, but it's fast and I can prove it.
Yeah. So I never took a trig class, and so the unit circle was always a thing that I just had never bothered to memorize. But you don't need it. You can come up with it when you need it.
No, yeah, my trig
Same
teacher,
thing.
she was like, memorize this, and I was like, I'm not gonna memorize that. I'll figure it out.
Yeah, I reject your suggestion for study tips and substitute my own,
Yeah.
much more laborious method. It's
Did
totally
the
fine.
exam. Got it.
So, you guys good with the gist of this? Okay. So, go forth and use this formula. If you want to write this on your Laplace transform sheet, go for it.
I think understanding that the concept behind this proof, what the constant, what's happening to the constants, and how it's coming about is really helpful. Remembering it.
Yeah, the thing I want you to take from this isn't the thing I want you to take from this really is that this formula isn't new magic. This formula is just the old formula, but with the i's suppressed. Which is really what you should be after anyway, because as an engineer, right, you're going to want to care about how this system evolves in time. And getting those imaginary solutions is an answer. But it doesn't tell you what, you don't know how to throw that into Desmos and get a graph for the picture, which is really what you're going to be after as an engineer.
This
Right?
one's can't do the complex plane.
There are calculator products that are good at it, but graphing in the complex plane is complex. Really, the problem with complex plane graphs is you have a domain space that's two-dimensional, you have a range space that's two-dimensional. You can't fit that into our usual three-dimensional coordinate system, and so what you end up doing are these weird paired pictures where you have the domain over here and the range over here, and you drag a dot around on this side, and you see how it moves on that side. They're pretty counterintuitive. It's the only thing you can do, but they're hard to analyze. So if you're looking for what does the long run behavior of my spring look like, this four-dimensional picture is not often very helpful. But this answer is oh, well, if the real part's negative, it's kind of acting like damp springs. If the real part's positive, then it's acting like anti-damp springs. I can see the kind of period of oscillation in some of these. We've got some stuff. Cool? Okay.